Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I will be covering stoichiometry involving delta H. So we're going to talk about thermochemical equations. We first have to figure out, or we have to learn what the delta H of a reaction is, or the enthalpy or heat of a reaction. So the enthalpy or heat of a reaction is represented by this delta H reaction. And this is going to reflect the stoichiometric amounts of reactants and products. And so the delta H of the reaction is basically the amount of heat either evolved or absorbed by the reaction given a certain number of moles of reactants or products that are reacted or formed. And so usually this is given to you along with a balanced equation. So the example of a balanced equation with an enthalpy of reaction given is the burning of propane. And so propane is C3H8 gas. And so this is telling us that 1 mole of propane requires 5 moles of oxygen to react completely to produce 3 moles of carbon dioxide and 4 moles of water vapor. And so given this balanced equation, then this will produce a delta H reaction of negative 2,044 kilojoules. And what that means is that given these stoichiometric amounts, then if we have 1 mole of our propane reacting with 5 moles of oxygen to produce 3 moles of carbon dioxide and 4 moles of water, then this is going to produce this amount of energy, negative 2,044 kilojoules. And remember, the negative tells us that the delta H of the reaction is negative, and therefore it is giving off energy. So it's losing energy. The reaction is the system again, and it's losing energy, therefore it's negative. So that's what the negative sign is telling you. So this is an exothermic reaction. So the great thing about this is we now have a relationship between the amount of product and reactant in relation to a given amount of energy. And so we can use these stoichiometric amounts. Again, remember, stoichiometry is referring to anytime you use the word stoichiometry, it involves a balanced equation. So you're using the relative amounts of products and reactants to solve a problem. So you can go from a certain amount of reactant to a certain amount of product. But now we can use the delta H of the reaction, the enthalpy or heat of the reaction as well. Because what this is telling us is that for every 1 mole of propane that we burn, we're going to produce 2,044 kilojoules of energy. Or another way to put it is, for every 5 moles of oxygen that is reacted, that's going to produce negative 2,044 kilojoules of energy. So we can now write this as a relationship or an equality. So if I write this, I could say that 1 mole of propane gas is going to equal negative 2,044 kilojoules of energy. Or I could write 5 moles of oxygen molecules, oxygen gas, is going to be equal to negative 2,044 kilojoules. Or I can relate it to the products. So for every 4 moles of water that's formed, that's going to equal 2,044 kilojoules of energy released. So remember what I said about having equalities. If you can have 2 things that are equal to each other, you can use that as a conversion factor. So I can now use conversion. I can now use the enthalpy of a reaction as a stoichiometric amount given the balanced equation, right? So now I can use this as a conversion factor. So I can put 1 mole of C3H8 on top over negative 2,044 kilojoules of energy. Or I can use this, or I can use this. So now what I see here is I can use these relationships, the molar amounts of the products or reactants. I can equate that with a certain amount of energy, and now I can convert between the amount of energy in a reaction and the amount of moles reacted. So I can figure out the moles of product, or the moles of propane, or the moles of oxygen, or the moles of any of the products that are formed. So I can convert between energy and moles of any substance that I'm interested in my balanced equation. So this is a good way of using conversion factors again. Remember, this will get you back onto these, the chemist's conversion superhighway, right? So if we are given energy is off of the highway, but if I have a balanced equation, I can take the energy and have it related to any of the products using the coefficients, and I can convert directly to moles of anything in my equation, and then I can go wherever I want. I can do a mole-mole conversion from moles of one thing to moles of another thing, and then I can go from moles of that thing to, say, I don't know, volume if they give me molarity. I can go to volume if they give me the ideal gas law and they give me pressure and temperature and all that. I can convert to grams using molar mass. So I can go wherever I want when I get to moles. So because I have my balanced equation. So in the next video, I'm going to go over a couple of practice problems where you can use the heat of the enthalpy of the reaction or the heat of the reaction to solve some stoichiometry problems. I hope you found this video interesting and helpful, and if you have any questions, please put a comment in the comment section. Tell me what you think, what questions do you have. If you like this video, share this video with your friends, hit the notification bell up on top, subscribe to the channel. Thanks for joining me, and I'll see you next time.